In this bell work, solving for the perimeter of that smaller triangle right there, it's really just a matter of using proportions like this. So I prefer fish method, but a lot of people prefer cross multiplication, but you get the same answer either way. And here's our objective. I can use roots to solve for unknown values, height, radius, diameter, or volume. Take a minute and copy that down, please. So in today's lesson, we're going to be looking particularly at volume formulas for circular type shapes, three-dimensional shapes, by the way, such as cones, cylinders, and spheres. And then we'll solve for varying unknowns in the formulas depending on what values they do give us. Before we get started though, just a little vocabulary on circles, okay, like this one. Remember that the perimeter around the circle, that's also known as circumference. Now we're not looking at circumference formulas today, but that should be at least a little quick reminder there. And right in the middle of the circle is a point, and we're going to pretend like I nailed just the middle of the circle right there, like the exact middle. That's called the center of the circle. We're not going to be quizzed on these vocabulary words, by the way. It's just important for you to know them, so if I use this vocabulary, you know what I'm talking about, all right? Now, the center is important because it creates other vocabulary. For example, if I were to take this point right here on the edge of the circle and then run a line that goes straight through, and we'll pretend like that's a straight line, all the way to the other side of the circle, that's what we call diameter. Right, but diameter specifically has to go through the center of the circle to the outsides of the circle. Now there's more vocabulary than what I'm giving you today, but that's for a different grade. Now if you go from the center just to the edge of the circle, like this, that is what we call radius. And yes, you should have learned this in 7th grade, but here we go. So radius like this, notice that it is also half the diameter because it only goes from one edge of the circle to the center, whereas the diameter not only goes from the edge of the circle to the center, but all the way to the other edge of the circle, okay? So radius and diameter, we can see that the radius is half the diameter, or that the diameter is double the radius, and you can kind of conclude some other relationships between those two, okay? But that's generally what it is. So remember on the previous lesson, now at least in the assignment, I think, where they said the area of a circle is pi times the radius to the power of 2, and they said solve for the radius. So remember, if you wanted to just manipulate all the formulas for cones, cylinders, and spheres, you could, and then you could use each formula to solve them, okay? Like on this one, we said divide both sides by pi. I made that a phantom 1, so then you got radius to the power of 2 equals area over pi. And then we said square root these, right? So the radius as a formula for the area from the area of a circle is the square root of area times pi. So you could use literal equations to do this every time, but we're just going to be, all we're doing on these ones is working with the formulas directly. We're not going to create new formulas like this, although you could. All right, so a cylinder, it's a solid obtained, so all you really got is a circle, and then it's kind of like three-dimensional, but it's straight up. These are related to prisms, if you remember prisms. It's just that your bases now are circles instead of triangles, quadrilaterals, or pentagons or something like that, okay? So, you'll see, at least if you remember, that the area of a circle is where you take pi. Now in 7th grade, they'd usually say something like radius times radius, but now that we're in 8th grade here, we're going to say radius to the power of 2. That's the area of a circle, okay? And yes, this radius, I don't know why it's pointing there. It should be pointing at this dotted line right here. But if you made a circle three-dimensional like we see here in the cylinder, all you got to do is multiply it by the height. And this would then give you the volume, all right? Now, as much as it'd be nice if you memorize this stuff, you don't have to, because we've got a poster for that. If you just look up here by the flag, you'll see the volume formula for cylinders. Now again, it's showing pi times radius times height. But again, we're going to be using radius to the power of 2 because we've seen some exponents, okay? So if you're wondering if you have to memorize it, you do not. But you will have to know what it is. All right, cylinder with a diameter of 8.8 centimeters and a height of 9 centimeters. And this one, we want to find the volume of the cylinder, okay? So volume, let's look at the formula here. It's pi times the radius to the power of 2 times the height. Now, the problem with this one is that it gives us the diameter, not the radius. But we know from what we talked about during the objective is that the radius is just half that. So if I want to find the radius, which I do, I'm just going to take the diameter, which I see is 8.8, and I'm going to divide it by 2. Whatever this is will be my radius. You can put that in the calculator if you need to, but it should be 4.4. That'd be centimeters, but I don't really need the label, okay? So I'm going to go into the formula now where it says where it has the radius, and instead of using r for radius, I actually have a value for that, which is 4.4. And yes, this is just like evaluating formulas like we did, I think it was in our second unit. It's like the first or third lesson, something like that, okay? But then in addition to that, they said, here's the height. Okay, well then I know the height, so I can replace the h for height with 9. And this will allow me to find the volume. In fact, I can type it in exactly like I see it. The pi, there's even a pi button. If you look in the top left where it has that second green button, you just go 3 buttons down and you'll see the pi button. So I'm going to push that button, pi. Then I'm going to multiply that by 4.4. And then I'm going to push that x to the power of 2 button. It's just 1 to the left of 7 to make that 4.4 to the power of 2. Then I'm going to multiply that by 9. Now I put it all in at once so that it's not just evaluating one part at a time or even using, we don't have to go through the order of operations because the calculator will do that for us. And this gives me the volume of 547. And yeah, the calculator gives us a big decimal because of pi, but I got 0.391104. I'm just going to round this to the 10th. So 0.39 would add 1 to the 3 in the 10th place value to make that 0.4. And since this is volume, and this is important, volume is 3-dimensional. So you can put, if you'd like, centimeters to the power of 3 because it's 3-dimensional. Or if you'd like, you can put 547.4 and you can just write it as cubic centimeters. It means exactly the same thing. For some of these problems like this one, we're going to have to be using the principles of equality. But we did that in the last lesson as well, so hopefully that's not too bad. So this one, we're looking at a cylinder, so let's look at the volume formula for a cylinder. It's pi times the radius to the power of 2 times the height. That's an h, by the way. And yeah, up here it says, here's your volume. So I replaced the v for volume with that value that was given, 117.1. And they also gave us the height here at 15 feet, looks like. So replace the h for height with 15. I'm using parentheses. You could just use multiplication if you'd like. Now we need to solve for the diameter. And diameter is not directly built into the formula, but radius is. And we know there's a direct relationship between radius and diameter. So once we find the radius here, then we will be able to find the diameter of the cylinder. Now I'm going to do this in 2 steps, although later on I'm going to show it in 1 step. So if you prefer to do this in 2 steps, you can. But like I said, later on, I'm only going to do this in 1 step. So here's what I mean. Is the first thing I would want to do is make, and this is my first objective here, is to isolate the r's. To do that, I've got pi and 15. I don't really want those with my r to the power of 2 here, okay? So I'm going to make these both phantom ones. So to do that, I'm going to divide both sides first by pi. You could choose 15 if you'd like. That's going to make that a phantom 1. All right? So then I'm left with r to the power of 2 times 15. And yeah, that became a phantom 1. So I'm going to put 117.1 divided by pi in my calculator. You can use the n over d button. You should get the same answer either way. I get 37.274. So I'm going to start rounding that right now to the nearest tenth. 37.27 makes that 37.3, okay? And now as my next step, I'm going to divide both sides by 15. Why 15? To make that a phantom 1. So now I'm left with radius to the power of 2 again. But this now equals 37.3 divided by 15. Let's see, I'm going to put that in the calculator. Divided by 15. And for me, and when I type it in exactly like this, I get 2.486 repeating. So I'll just make that 2.5. Okay, so that's the radius to the power of 2. All I really need, though, is the radius. So to do that, I'm going to square root both sides of that equation. Right, whatever you do to one side, you got to do the other side. So the radius then equals, let's see, square root in the calculator of 2.5. I got 1.58, 1138, and some change. So I'm just going to make that 1.6. 1.58 would round that to 1.6. So that's my radius. And yeah, if you want to show that in feet, that's fine. But we actually don't want just the radius. We just want the diameter, okay? So to find the diameter, I'm going to take my radius, 1.6, and I'm going to multiply that by 2, which gives me a new diameter of 3.2. And yes, this is diameter. It's just one-dimensional, so it's just a matter of feet. The diameter is 3.2 feet. And yes, we usually just use D for diameter. If we saw a C, then that'd be circumference, but we shouldn't see any of that in this lesson. All right? So this is where we see some of the square root stuff that we did in the last lesson, particularly when we solve for R in these formulas, because we're dealing with circular type three-dimensional shapes. And so we see a lot of R to some power. So for solving for R, then we need to use roots. The volume of a cylinder is 4,224.8 cubic millimeters. It has a diameter of 16.4 millimeters. Find the height of the cylinder. So again, we're looking at a cylinder here, so we need the volume formula for a cylinder, which is pi times the radius to the power of 2 times the height. And yeah, this one we're solving for the height in this one. So we should be able to use direct principles of equality, okay? Now, the volume was given, so I'm going to be replacing the V there with the volume that was given, the 4,224.8 cubic millimeters. They didn't give us the radius directly, though. So just remember that the radius, it's the same thing as taking the diameter here at 16.4, but you'd have to divide it by 2. Right? So that'll give us the radius. 16.4 divided by 2, I get 8.2. You can put millimeters if you'd like. And that means I can replace my R for radius with 8.2. So yeah, the H is missing. There's always got to be one of these values missing. And yeah, pi is just a constant value. That's why it's a button on the calculator. And so of volume, radius, and height, they usually just will miss one of them and then got to solve for the missing one. So if I was doing a problem like this, I would probably evaluate 8.2 to the power of 2 first. So I'm just going to put that in the calculator. 8.2 to the power of 2, I get 67.24. And while we are going to be rounding to the nearest tenth, I'm going to keep that as 0.24. So my new equation after just that evaluation, 4,224.8 equals pi times that 67.24. And you can put in parentheses if you need to, times the height. Now in that last problem, I said that I did it in 2 steps. I'm going to do this in 1 step, okay, to solve for the height. What I'm going to do is I'm going to divide this, both sides, right? Because if you do it to one side, you got to do the other side, by not only pi, but pi times 67.24. And yeah, you can do that. In fact, in our calculators, this means that I'm going to be using the N over D button. Because pi divided by pi is 1, 67.24 divided by itself is 1. Anything divided by itself is 1. I'm just going to make those phantom ones. What I get from this in my calculator will be the height. So I'm using the N over D button, 4,224.8 in the numerator, pi times 67.24 in the denominator. I get 19.99993467 in my calculator. So rounding that, of course, to the nearest tenth means that you'd have 20, millimeters. And this would be our answer. So, volume of cones. Cones are actually pretty directly related to cylinders in this way. Now, here's the thing: is if you took this cone right here, let's see, and you put it inside this cylinder, you'd end up with something like this. Okay, we'll pretend like I'm a good drawer. Now we know the volume formula for a cylinder. As it turns out, a cone is only a third of that. Okay, so if you filled this cone 3 times and poured it into the cylinder would be completely full. All right. So that means when we make the formula for the volume of a cone, all we're going to do is divide it by 3. Now this is one way to do it. I'm actually going to be using the formula slightly different, although it is the same. The volume of, this is a cone, is going to be pi times the radius to the power of 2 times the height. But I show it as all over 3 like this. Okay. Again, it doesn't matter. You'll still end up with the same answer. But usually when we solve for either radius or height, this formula, at least for me, is more preferable. But it doesn't have to be preferable to you. You can choose whichever way you'd like. So find the volume for each cone described, no problem. We'll round to the nearest tenth. A cone with a radius of 8.4 feet and a height of 5.5 feet. So this one gave us the radius directly. And we know the volume for a cone is pi times the radius to the power of 2. And again, that radius to the power of 2, it should look familiar, times the height. That's the volume for the cone, for the cylinder, but the cone is just a third of that. Okay, so divided by 3. And yes, they gave us first here the radius at 8.4. So I'm going to replace the radius with 8.4. And then I'm going to replace the height, which was given, 5.5 feet. Okay. And yeah, this formula can be plugged directly into the calculator. Whatever it is would be my volume. Now again, for me, I'm using the N over D button, the fraction button on the calculator. And then in my numerator, I type pi times 8.4 to the power of 2. So I'm using the x to the power of 2 button just to the left of 7 times 5.5. Then I go to the denominator, I just put in the 3, enter, and it gives me the answer, 406.396. So I'm going to make that 0.4. Because like I said, I'm going to be rounding to the nearest tenth on these. Now, again, this is feet to the power of 3 because it's volume. Or, if you'd like, you can write it as 406.4 cubic feet, if you prefer. Now, again, if there really is no expectation to memorize this formula, I mean, you may just because you may use it enough. But it is on the poster up there by the flag as well. It's a different poster, but it's for cones. A cone with a diameter of 9 meters and a height of 4.2 meters. Okay, and yeah, we're going to solve for the unknown, which in this case would be the volume. So let's look at the formula. The volume for a cone is the same volume for the diameter, just divided by 3, right? So pi times the radius to the power of 2 times the height all over 3, divided by 3. And what they give us on this one? They gave us the diameter at 9 meters. So I'm going to take my diameter at 9 meters. The diameter, if it were 9 meters, then, but I want the radius, right? But the radius is going to take the diameter at 9, and you'd have to divide that by 2. So that tells me that my radius would be, I'm going to use the decimal. You can use the fraction on that if you'd like, because we're just putting this in the calculator. That's in meters, so my radius now is 4.5 meters. So I replace my r in the formula, radius, with 4.5. And yeah, they gave us the height again. So I'm replacing the h height with the value they gave us at 4.2 meters. Okay? But again, this is just, I'm just going to put this directly into the calculator. Whatever I get from that formula is the answer. So N over D for me, pi times 4.5 to the power of 2 times 4.2 all over 3. And I get 89.064 and some change. So I'm just going to write that as 89.1. Again, this is volume though, and we're looking at meters. So meters cubed or cubic meters, doesn't really matter, it's the same thing. The volume of cone is 122.8 cubic inches and its height is 4.5 inches. So yeah, we're going to be solving for the diameter, it looks like. Now remember, even in the formula, the diameter is not shown, but the radius is, and that's all we really need on this one. So volume for a cone, pi times the radius to the power of 2, times the height, all over 3. All right, and what they give us? They give us the volume right here at 122.8. So again, that V right there, I'm going to replace with that value that was given, 122.8. And then the height at 4.5 inches. Right? So again, since we're solving for the radius on this one, that indicates that we're going to be using roots in this problem, just like we did in the last lesson. So to solve this equation though, principles of equality, just like we've seen before, first thing I would do is multiply both sides by 3. Well, why would we do that? It's because I want to get rid of that divide by 3. And by get rid of, I mean make it a phantom 1. All right? So that gets rid of it completely, or that we don't have to look at it at least. So that gives us pi times the radius to the power of 2 times 4.5. And this equals, let's put this in the calculator, 3 times 122.8. And I get 368.4. Now, just like I did on the previous couple problems ago, at least, at this point, I'm going to divide both sides. Now, again, you could do it in 2 steps, but I'm going to do it in 1. Not only am I dividing both sides by pi to make this a phantom 1, but I'm simultaneously going to divide by 4.5, or just at least put in the denominator, like this. So that would be like pi times 4.5 right there. Why do that? Well, it becomes a phantom 1 there, which leaves me with just phantom 1s and r to the power of 2. So let's put this in the calculator. Again, I'm using my n over d button because that's the way that I have it written. 368.4, and in my denominator, pi times 4.5. And I push equals or enter, and I get the radius to the power of 2, which is 26.0589, so I'll just make that a 0.1. And then we need the radius, and that will then help us find the diameter. So I'm going to take the square root of both of these, because remember it's a power of 2, so we're using a square root. That will give me just the r. And so in my calculator, I push square root of 26.1. Remember, the square root, to access it, is just second, and then the x to the power of 2 button. I push enter, and I get 5.1088 and some change, so that's just going to be 5.1. Now, that's the radius, though. I want the diameter, and the diameter is double the radius. So that's what we're going to do for my diameter. I'm going to take my radius, 5.1. Oh, thank you. And I'm going to double it. 5.1 times 2, boom, 10.2. And this is in inches. Looks like. There's our answer. Volume of spheres. Spheres aren't really related to cylinders. I mean, they are, just to show that really makes it more confusing than it needs to be. So I'm just going to show you the formula like this. Now, again, I show it actually a little different than what's seen right here. So my formula, it's going to give you the same answers, by the way, but I would take 4 times pi times the radius to the power of 3. And then again, I prefer to see this in a fractional form like this, because when we're solving for radius, it just makes it usually just a little bit easier. Now, notice that there's only 2 variables in this, the volume and the radius. That means they have to give us one or the other, and then we just solve for whichever one's missing, okay? Now, you could use literal equations to solve this, by the way, if you wanted to. So we're going to be finding the volume of this sphere, a sphere with radius 1.3 yards. Remember, they have to give us one of the 2 values, either the radius or the volume. This one, they've given us the radius. So here's the volume formula for a sphere. 4 times pi times radius to the power of 3, all over 3. And yeah, what they give us? The radius here. So I'm going to replace my r, radius, with 1.3. Well, this is something I can just plug this directly into the calculator. And again, I'm using my n over d button. You can just put 4/3 in there and then multiply by pi and 1.3 to the power of 3. But I'm going to make it all a fraction. So 4, and so I push the n over d button, 4 times pi times 1.3 to the power of 3. Now remember, to access exponents that are bigger than 2, you got to use the exponent button. That's one button to the left of 7 and one button up. So that's the button I'm using, to the power of 3. And then you'll have to use the oval cursor to get out of the exponent function. So I push over and then down to go to the denominator, put in my 3, enter. And I get 9.2027 and some change. So again, I set around to these to the nearest tenth. So 9.20 would be 9.2. In this case, that's a yards cube. Or again, if you'd prefer 9.2 cubic yards, it's the same thing. On this one, we're going to find the diameter of the sphere because they've given us the volume. So remember, volume formula for a sphere, or if you don't remember, just look at the poster, but that's 4 times pi times the radius to the power of 3 all over 3. So there's my R for radius. And yeah, they've given us the volume right here. It's 6,882.3 cubic inches. I'll need a little bit more space there. So I'm replacing the V for volume with that value was given, 6,882.3 cubic inches. All right? So I'm just going to use principles of equality to solve this. First, I'm going to multiply both sides by 3 to make that a phantom 1. And so I'm left with 4 times pi times the radius to the power of 3. But this is going to equal, right, because we made that a phantom 1, so we're just left with the numerator. Let's see, 3 times 6,882.3 equals, I got, from my calculator, 20,646.9. And again, while you can do this next part in 2 steps, I'm going to do it in 1. So I'm dividing both sides by not only 4, but 4 times pi. If I do it to one side, I got to do the other side. So that becomes a phantom 1 right there. I'm left with my radius to the power of 3, which is what we wanted. But over here, I got to type that into the calculator. So 20,646.9 all over 4 pi. Again, I'm using my N over D button on this. I get 1,643.02, so just 0.0. And yeah, I want my radius to figure out the diameter on this one, so I'm going to take the, not just the square root on this. Remember that exponent's 3, so I need a cube root on these. So that will give me my radius. Remember the cube root, I got to push 3 and then second, then it's the exponent button. That'll change that root into a root 3, third root, a cube root. So then I got my cube root, 1,643.0, enter. I get 11.799 and some change. Rounding that would be 11.8 inches. Well, we don't want the radius, we want the diameter up here. Find the diameter. So the diameter is when we're going to take the radius, which is 11.8, and I'm going to multiply that by 2. That will be my diameter. So 11.8 times 2 equals 23.6. Again, there's just inches on this one because it's one-dimensional. So that's it. The volume of a sphere is 1,436.8 cubic feet. Find the radius of the sphere. Okay, no problem, because we know the volume formula for a sphere, which equals 4 times pi times the radius to the power of 3 all over 3. And yeah, what they give us on this one is the volume right here. So I'll replace that volume with that value. 1,436.8 cubic feet. And so we need to go into our principles of equality to solve this. Once again, multiply both sides by 3 to make that a phantom 1. So I got 4 times pi times the radius to the power of 3, which equals, let's see, 3 times 1,436.8 equals, in my calculator, 4,310.4. And then, just like we saw in that last one, we're going to divide both sides by 4 times pi. So that becomes a 1. And so I'm left with my radius to the power of 3 equals, let's put this in the calculator, n over d, 4,310.4. I go down and I type in 4 pi, and I get 343.01, so it's just 0.0. Of course, we want the radius, just the radius on this one, so I'm going to cube root this because of the exponent of 3, which will leave me with just the radius. So let's cube root 3-second exponent button, 343.0, and I get 7. It's 7 exactly. So that means this would be 7 feet. That would be my radius. Well, here's our objective. I can use roots to solve for unknown values such as height, radius, diameter, or volume. At least for these 3 formulas, right? Cones, cylinders, and spheres. Hopefully we feel pretty comfortable about that.